In our next example, we're again going to forecast, but instead of using the naive approach, we're going to use the average of past values method. So we're going to recreate table 6.8 and then calculate our errors from section 6.2 of the book. So the difference here is going to be our forecast column. And again, instead of the naive approach, we're going to use the average of the past values method. Now, however, our first forecast, or our forecast in week 2, the only past value is 17. Okay. Now, in week 3, here's where we start to get into a more complicated equation, but we can just use the Excel function. So equals average, and we want the average of the previous 2 periods. But we would like to lock in this first one because we always want to start here and then we just want to drag down and have as many as we need. Okay, so now we can drag this down because it has anchored our cell reference. So we are always starting at B4. Check down here, still starting at B4, getting the average of all these periods. Check again, looks good. Now we want to clean this up just a little bit. And there we go. So now our next task again is to calculate the forecast error. So that is our time series value minus our forecast. Copy it down. Absolute value of forecast error, same as we did in our last example, equals ABS. Select our value, close parentheses, relative cell reference, so we can carry our formula down. Let's clean it up a bit. Then move to the squared forecast error. So equals that squared. Again, copy it down. Percentage error, again we want equals E sub t divided by our time series value, our y. It's in a percent with 2 significant digits, good, carry that down. And finally the last column, the absolute value of percentage error. So again, equals ABS, parenthesis, select our value, close parenthesis, copy it down. Now our next task is going to be to calculate our errors. So we know before we can do that, we need to get some totals here, calculate some sums. So total equals sum here. And we want sums all the way across, And remember, these two need to be in percent. So there we go. If you need a reminder, you can go ahead and do something like this. Now we want to calculate our mean forecast error. So remember, here are our equations, and our mean forecast error equals the sum of our errors, sum of E sub t, so equals this sum divided by n minus k, that is the same as before, 12 minus 11, and this can be a bit confusing to look at as a percent. So let's just take and make this general number, wrong way, 2 decimal places, or 3 decimal places, 4.524. Okay. Now mean absolute error, again, here's our equation, equals the sum of the absolute errors divided by n minus k, 2.437. Moving down, mean squared error equals the sum of our errors squared divided by n minus k, 8.097. And finally, mean absolute percentage error equals the sum of our percentage error divided by, once again, n minus k, 12 minus 1. 12.85%. Remember, mean absolute percentage error should in fact be a percent. So now we're tasked with calculating our week 13 forecast. So again, we need to average all the prior weeks. So equals average of weeks 1 through 12 for 19.25. So again, in this example, we again forecasted, but this time using the average of past values method. We recreated table 6.8 in the book and then calculated our forecast errors, our absolute error, our squared error, and our mean absolute percentage error.